Your life. Okay, so the topic today really is functions. But mostly today we're going to be evaluating. Okay, so first of all, let's go ahead and review what a function is. Okay, it is where every element in the domain is paired to exactly one element in the range. Okay, that is the true mathematical definition. Okay, every element in the domain, X's, right, Landon?
Yes.
Is paired to exactly one element in the range, the y values. Okay, so let's put that in there. Let's make sure we know that the domain is the x values, right? So it makes a little bit of sense. So that's my x's, and those are my y's, right? So this is a fancy word, a fancy way of saying that every x has exactly one y. Okay, because we know the domain is the x's, right? We know that the range is the y values. Okay, so let's go ahead and go back to this whole coffee stand thing. Okay, so example 1, the coffee stand, graph both. So coffee is 2 for $3. So we can graph that. So we know that our control variable has to be the number of lattes. So I'm going to go lattes, number of lattes. So there's 1, 2, 3, right? So my control variable is the number of lattes. And then my dependent variable is the cost, right? So then I've got my cost up here, and we'll just go $3, 6, and 9, okay? So coffee's 2 for $3. That makes sense. They do that sometimes, right? That sounds like a perfectly legitimate question. So if I bought one latte, it's going to cost me $3. If I buy a second latte, if I buy two, it's for $3, okay? That's a function, okay? That is a function. Every x has exactly one y value. Every x has exactly one y value, right? Now the next one is Emma's crazy latte stand. Okay, let's take a look at it, okay? So, number of lattes, that's my control variable. So I've got 1, 2, 3, and then the cost, which is my dependent variable. There's $3. $6, okay? So, $2 and $3. So if I buy a latte, it's going to cost me $2 and or $3. So I'm a little confused. Is it $3 or is it $2? Can't be, right? Not a function. We have an x value that has two y values, right? Now, there's a thing called a vertical line test. Am I going too fast? No. Okay. There's a thing called the vertical line test. If you can draw a vertical line through any graph, and if it hits the graph anywhere, if it hits the graph in more than one place, it's not a function. So if we try the vertical line test on this one, let's see, here's my marker. And I just drew straight down, vertical line, hits it once, right? Hits it once. This passes the vertical line test, therefore it's a function. Thumbs up. Second example, it hits it once, twice. It's not a function, okay? Because you have an x value with two different y values, okay? So far, so good. Now, let's look at example 2. All right, if I look at example 2, A, function or not a function? No, not a function because it fails my vertical line test. If I just draw it down, it hits it more than once, so it's not. Right? Everybody agree? How about B?
Yeah.
It is, because this is an open circle, so it passes through this, passes through, doesn't hit a point, and keeps going. So this one's yes. It's what we'd call a non-continuous function. Non-continuous doesn't flow away, but it's still a function, okay? How about C? Is this a function?
No.
Where does it fail?
Because the two black dots.
Right there. So it fails there. You've got an x value with two different y values, so you say no, it's not. No. Not. Good. Easy? Thumbs up, everybody? Okay, how's this for pre-calc? Slow enough? Okay, good. Okay, example 3. This is a question. What does it mean? It's a question. What does it mean? Yeah.
What will y equal when x equals -2?
Okay, what will f of x or y equal? Remember, y and f of x are the same thing when x equals -2. So let's plug in. So we're going to plug in x equals -2, and we'll find out what the f of x or the y value is, okay? So we'll plug it in. We'll go f of -2. Okay, that's part of the question. Equals. Okay, that's the question. F of -2 equals 3 times -2 squared plus -2 minus 4. I'll slow down for a second, let you catch up, okay? All right, so I'm just plugging in -2 for x. Okay, everybody good on that? Okay. So let's figure it out. So f of -2 is equal to 3 times a positive 4 minus 2 minus 4, right? So f of -2 is equal to 12 minus 6.
What did you get?
3 times 4. That's okay.
Oh, okay, I see.
And then f of -2 is just 6, okay? Now, here's what Evan said. When x is -2, he said y. He said y is equal, because f of x, we're going to say f of x, and y are the same thing, okay? So it's a point. So technically on a graph, this is a point. On the graph, it's a point at -2, 6, okay? So if you were to take a look at this graph, it's parabola, you'd have a point on the graph at -2, 6. Plug in -2 for next value, get a corresponding y value of 6, okay? Thumbs up? Okay, good. Now, B can be a trick question. Be careful. What does it say? So I'm going to put the 0, let me go ahead and show you. I'm going to put the 0 there. F of x is 0. So don't write f of x, write 0. Okay? So write 0. So we're going to go 0 equals 3x squared plus x minus 4. Now solve for x. Ooh. Wow. Okay, Evan, you might have to help me out. We'll see if anybody knows how to do this, okay? How are we going to solve for x? Factor! Yeah!
No way.
Landon might be the new smart kid, huh? I knew he was going to say no to that. Maybe. So 3x, x. Okay. Sydney, you remember factoring?
Yeah.
Good. That was a good answer. I like that. Here you go. 3xx, because that'll make a 3x squared, right? I'm not going to go 2 and 2. I'm going to go 4 and 1. I'm going to put a 4 here and a 1 here because that'll make a 4, right? Now, why am I doing that? Remember the double smiley?
Double frowny.
Remember the double smiley? Or Landon, didn't you call it upside down frowny?
No, I call it right side up frowny.
Whatever. Okay, let's see. What do you got? Okay, so 3x, 4x, right? But we need to make a 1x. Remember that? Do you remember that at all? Okay. I've got my 3x squared, but here that's a 3x and that's a 4x. If this were a positive and that were a negative, would that work?
Yes.
I think so, for foiling, right?
Hello.
Yep, factoring. Okay, so I'm going to go a positive 4 and a negative 1 because they'll make, okay, if you guys remember this, outside inside makes a negative 3x and a positive 4x, and together they make a positive 1. Pretty good with that?
Wait. Yes.
Okay, sure. It's been a while. I mean, it's been a year since you guys have factored, or maybe a summer, right? So, okay, let's get rid of that. So now I'm not done. Solve for x. Solve for x. What do I got to do? I don't know. Me neither. What do you got, Evan?
You do the mini equation.
Remember the mini equations? Remember the mini equations? So you got 0 equals 3x plus 4, and we got 0 equals x minus 1. Remember the mini equations? Because we want if x equals 0 here, it's 0. If x equals 0 here, it's 0. Right? If x equals 0 here, it's 0. If x equals 0 here, so obviously 1. If 1 is here, you agree with 1. 1, because 1 minus 1 is 0, right? So if we solved it, that's easy. With plus 1, we get one answer is x equals 1. And then minus 4 on both sides, divide by 3. So these two x values, if you plug in either one of them, if you plug in either 1 or negative 4/3 into x, it will make it 0. Okay? It will. You can try it if you want to, but believe me, it will if you plug them in. Okay? Thumbs up. Factoring is a little stretch for you today, I know, but all right, let's turn the page. All right. F of A. F of A, what does that mean?
Nobody knows.
Well, it's a question. What is the question? That is a question. What did we do before? It was f of negative 2. What did we do?
It's the same everywhere.
Yeah, except for we're going to plug in a. So it's just going to be a squared plus 2a minus 8. Right? Right? Okay, what about f of a plus h? Sorry, Evan. Forgive me, Evan. They'll let you answer every single question, I promise. They'll be happy. You're going to be the golden child. They're going to love you, Evan. Sorry, Evan. You're like, go ahead, Evan. Tell us how. Come on, you guys. What does this mean? F of a plus h.
Distributing property.
Well, what do we do here? What do we do here? We plugged in a. So we're going to let's plug in a plus h. Let's just plug it in. So where do we plug it into? Into the x, right? So we're going to have a parentheses a plus h squared plus a 2 times an a plus h minus 8. Okay, all I did was I put a plus h into x and into x. You okay with that? Okay. Now we're going to simplify this a little bit, okay? Because we're going to FOIL. We will FOIL. Okay? We're going to FOIL here. Okay? Or distribute. Or we'll distribute. Okay? So this is correct. This is not wrong. I'm just going to expand it because it's going to help me with my next question, okay? So a plus h squared really is the same thing as an a plus h times an a plus h, right? Something squared means it's multiplied to itself, correct? Plus a 2 times an a plus h minus 8. Okay, so the only step I did is I wrote this twice, okay? Because something squared means times itself, okay? Now, let's distribute, Landon. Okay, let's distribute. So a times a. Good. Okay, now hold on to your hat. A times h.
AH.
Good, it is. Plus AH. Nice. H times A.
HA.
Yes, but I'm going to call it AH, okay? And you'll see why. HA is correct. Yes, there you go. Plus AH. HA is correct. Let's write it as AH, okay? And then H times H. Good. Okay, any questions? Am I going too fast on this? Okay? If you take calculus, I'm just saying, if you take calculus, this is done a lot. That's why we are going to practice it nice and slowly, okay? Now, plus 2a plus 2h. Okay, do you know where I got that from?
Yes.
Now, what do we see? What can we combine?
The AH.
Yeah, there's two of them, aren't there?
Yeah.
Okay, you agree with that? Okay, Zoe says combine those two. AH plus H, there's two of them, so let's go A squared plus 2AH plus H squared plus 2A plus 2H minus 8, okay? I don't think I can do anything else. That's it, right? Okay, now. C.
Oh wait, that's it.
Wait, that's it?
Well, I don't think I can put anything else together, can I?
Wait, what was?
Wait, should we?
Is there anything else that's the same? Do you see anything that we can combine? Am I missing something?
No, you're not.
I mean, I've got AH's, A squareds, H squareds, A's, H's, right? And just a constant, so I think that's all I can do, right? Now see, here's where it becomes hard if you aren't paying attention, but you guys will get this, okay? So, you ready? F of A plus H. That's this. Okay, hold on really quickly. That is that right there, isn't it? We just did it. We just did F of, okay, right? Subtract F of A. That's that one there. So let's subtract these two. Let's take this answer and subtract this answer. Okay, now this is where it gets hard, but I know you can do it. So the symbolism says take F of A plus H. We did that, right? Subtract F of A. Well, we did that. So let's take this one minus that one, okay? Let's do that. And then we'll do the divide by H last, okay? So, all right, what does this mean? So we're going to take our A squared plus 2AH plus H squared plus 2A plus 2H minus 8, subtract. Now I'm going to use parentheses because I need to subtract the whole thing. So I'm going to use parentheses so I get the whole thing tucked in there, okay? Subtract A squared plus 2A minus 8, okay? So here's what I have. I've got A plus H. I got that, right? So take this one and then subtract the other one, right? Now, divide everything by H. You're like, what are you doing? Right? Just go along with you, okay? Go along with you, okay? This is a pre-calculus problem, okay? And that's what we need to learn. All divided by H, because that's what it says, right? Now, what a mess.
Yes.
But luckily, some things will happen and make it a little bit easier, okay? So, let's see. Did you see anything? There should be 3 things that should cancel. 3 things should cancel. You guys see anything to cancel? A squared to A squared. You guys agree with that? A squared minus A squared. Boom. Nice. Okay, what else?
2A.
Okay, and 2A with a 2A. You guys agree? 2A minus 2A. You guys agree with that? And the 8s, because you got a negative 8 minus a minus 8. Now, minus a minus makes it a positive. So you got a negative 8 and a positive. Do you see that? So that cancels with that, okay?
Wait, what cancels with what?
So 8s. The 8s cancel, and I'll show you why.
Because they're both negative.
So double negative, right? So you get double negative here, so this really is like a positive 8. So you got a negative 8 with a positive 8, right? You see the double negative here? Double negative,
Oh, I see.
which makes that a positive 8. So this negative 8 with this positive 8 cancels, right?
Okay.
Okay, all right. How am I doing, okay? So let's see what we have left. Okay, I'm going to rewrite it, see if I can simplify it, okay? This is, if you do take calculus, it's such an important concept to get. Yeah.
We cancel the opposites?
Yes, we did.
Okay, but then why didn't we, like, I'm just confused. Why did we cancel the A squares?
Good. A squared, subtract A squared. Nothing. 0. Gone.
Oh, but so they're 2 different things.
Right, right. So, or one way, Landon, is you could bring, remember how we used to bring the negative through? You could have made that a negative A squared, a negative 2A, and a positive 8, right? Does that help you bring the negative through?
Yeah.
And then you can see it.
Canceling the A's and canceling the 8's are 2 different things, but we still cancel them.
Yeah, yeah. So anything that's the same. A squared minus A squared, gone.
Okay.
2A minus 2A, gone. Negative 8 and a positive 8, gone. So what's left? So we'd have a 2AH plus H squared plus 2H all over H. Okay, what's left, right? That's everything that's left, okay? Okay. Okay, one last thing. What can we do? Is there anything else?
Cancel
Cancel what?
the H.
We can, and I'm going to, yes, totally right. I'm going to show you an in-between step to make it seem more obvious, but if I factor out an H, 2A plus H plus 2, okay, you don't have to do this step because Zoe, what you said is correct. We're just going to cancel an H, cancel an H. But it's easier to see if you factor out an H. So I common factored out an H, So common factor out an h. And this h cancels with this h. And what are you left with? You're left with an answer.
Wait,
2a plus h plus 2.
what did you do to make it different?
So I see they all have an h in common on top, right?
Oh, so
So I pulled out a common h. Pulled out an h out of here. Pulled an h out of here. And pulled an h out of here. Okay? These h's cancel. Now this is a huge concept in calculus, but they'll take it much further. We're just going to look at a little piece of it. So if you take calculus, you're going to go, I know how to do that. Mr. Davies showed me how, right?